So in this section, we are going to talk about analyzing the graph of a function. And when we analyze, we're going to answer all these questions, A through G. So first thing I want you to do is I want you to look at your graph that's in your media notes. And in the graph, I want you to notice that we have a few points that are kind of highlighted. So this point is negative 2, 5, negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, and then 4, comma 5. So let me label these. This point is negative 2, 5. This point is negative 1, 0. This point is 0, negative 3. This point is 1, negative 4. This point is 2, negative 3. And then this point is 4, 5. Now let's go through and answer these questions. The first question says, what's f of negative 2? So first of all, f of x equals to y. So whatever is in the parentheses, if f of something, that is your x value. And what it equals to, that's your y value. So because we're asking what's f of negative 2, that means this negative 2, that is your x value. And we're asking, what is the y value when x is negative 2? That's what f of negative 2 means. It means, what is the value of the function when x is negative 2? All right, so when x is negative 2, the value of the function is 5. The point of the function is negative 2, 5. So f of negative 2, that equals to positive 5. Okay, what's f of 3? So this is asking, when x equals to positive 3, what is the y value? It's always f of x equals y. That's your x value, that's your y value. So when x is 3, so we have 1, 2, 3, and I forgot to label this point. This point is 3, 0. When x is 3, the y value is going to be 0. So f of 3 is going to be 0. And again, I want you to remember that this is asking, what is the value of y when x equals to 3? Okay, now we have f of 1. So f of 1 is asking, what is the value of y when x equals to 1? So x equals 1, what is y equal to? So on the graph, if you look at x equals 1, y equals to negative 4. And that's given by this point, 1, negative 4. X is 1, y is negative 4. So f of 1 will equal to negative 4. Okay? Part B, it asks for domain. Okay, now, domain, we learned in the previous section, this refers to all the x values that have a real solution. So in other words, if you look at it from the perspective of a graph, what are all the values of x for which there's a y value on the graph? Okay, so for example, for x equals negative 1, we have a y value. For x equals negative 2, we have a y value. It's 5. Well, what about for x equals negative 3? Even though it's not labeled, this arrow tells us that this graph is going to keep going this way indefinitely. So for x equals negative 3, you'll have a y value. For x equals negative 4, you'll have a y value. And because this graph is going to keep going this way indefinitely, that's what this arrow represents, the x values keep getting smaller and smaller. And then same thing on this side. For x equals 3, y is equal to 0. For x equals 4, y equals to 5. But this arrow tells us that the graph doesn't stop there. It's going to keep increasing this way forever. So when x equals 5, you'll have a y value. When x equals 6, you'll have a y value. So the x values, they keep growing indefinitely in each direction. So the domain is going to be negative to positive infinity. This tells you that for every x value, there's a y value on the graph. So if you look at this graph, for every x value, you have a y value. It's not shown necessarily because of this arrow. The arrow tells you that you keep going forever in each direction, but for every x value, you will have a y value. Now the range, this talks about y values. So the range is asking which y values are represented on this graph. Okay, so let's take a look at this side. So 5, and then 6, 7, 8, 9, all those y values are represented because this arrow means that the y values keep getting bigger and bigger. Okay, now let's look at this side. We have 0, negative 1, negative 2, negative 3, and negative 4, that is the lowest y value. There is no y value of negative 5 on the graph, or negative 6, or negative 7. So our lowest y value is negative 4, And on this side, the graph goes on indefinitely. So in interval notation, remember, interval notation is the lowest value and the highest value. So the lowest y value on the graph is this one, -4. That's the lowest y value on the graph. So in interval notation, our range, we're going to put -4. And we have a bracket on that because the y value of -4, that's included on the graph. So we have a bracket. Now what about the high y value? Well, there is no high y value because the y's keep increasing indefinitely in the positive direction. So the y values go to infinity. I want you to notice the difference between the domain and the range. The domain talks about the x's. The x's keep going indefinitely each way. So for every x value, there will be a y value. It's not the same thing for the range, because for the range, we're looking at the y values. The lowest y value is -4, and then the highest y value, there is none. So it's gonna be infinity. Okay, intercepts. For the intercepts, we want to list the x-intercepts and the y-intercepts. So let's make two different categories. The x-intercepts and the y-intercepts. So remember that the x-intercepts are the points where this graph is going to cross the x-axis. So the x-intercepts, well, this is your x-axis, and the graph crosses the x-axis at 2 points, here and here. So our x-intercepts are going to be -1, 0, and 3, 0. And from the section in lines, we learned that x-intercepts have a y value of 0. So we can just look at which points have a y value of 0, and those are going to be your x-intercepts. The y-intercept is where this graph crosses the y-axis. So this is your y-axis, and the graph crosses the y-axis at this point. And that point is going to be 0, -3. So the y-intercept is 0, -3. Another way to think about that is the y-intercept is when the x value is going to be 0. So we have 0, -3 as your intercepts. Okay, part E, which I erased, says, for which value of x does f of x equal to 5? Okay, so for which value of x does f of x equal to 5? Now remember, over here we said f of x equals y, right? So this is the y value. We're asking for which value of x is the y value equal to 5. Okay, so let's take a look at that. This is y equals 5. This value up here is y equals 5. So for which value of x does y equal 5 on this graph? There's not just one, there are two. For x equals 4, y equals 5. And for x equals -2, y also equals 5. So for when x is 4, y equals 5. When x is -2, y equals 5. In other words, we can rewrite this as f of 4 equals to 5, and f of -2 equals 5. X is 4, y is 5. X is -2, y is 5. So this will be your answer. For x equals 4 and -2, f of x will equal to 5. Okay, next. Where is the function increasing and decreasing? So this is going to be kind of tricky because we have two different quantities. We've got the x values and we've got the y values. So when the question is asking, where is the function increasing? Here's what it's asking. It's asking for which values of x. So we're looking for the values of x. Are the y values increasing? Okay, I'm going to get rid of all this on this side. So the question is asking for part F, for which values of x are the y values increasing? For which values of x are the y values increasing? Whenever you read a graph, you always go left to right. Okay, you always read a graph left to right. Now let's look at the y values. Here, the y value is 5. Here, the y value is 0. So the y values are decreasing. We're going from 5 to 0 to -3, and then to -4. After -4, guess what happens? The y values start increasing. We go from -4 to -3 to 0 to 5, and then so on and so forth. So I'm going to highlight the part where the function is increasing. The function is increasing when the y values are increasing, going left to right. So the y values are increasing on this section of the function, the one that I'm highlighting in red. Okay, going left to right, this is where the function is increasing in values. And you can see that. Y values are -4, -3, 0, 5, so the y values are increasing. Okay, so that only tells you, that helps you identify the part of the function where the y values are increasing. But the question is, for which values of x are the y values increasing? So the y values only tell you which section of the function to highlight. But we're looking for the x values where the y's are increasing. So what about the x values? Well, the function starts increasing here when x equals to 1, and then it keeps increasing indefinitely. Okay, so how do we write that? The function starts increasing, so remember, we're looking for the x values now, not the y values. The y values tell you where the increasing portion takes place, but we're looking for x values where the y's are increasing. So this portion of the function, if you were focusing on the x values, it starts at 1, and then as the x's get bigger and bigger, the y's also get bigger and bigger. So the function keeps increasing on this portion, so it's going to be 1 to infinity. But we're looking at the x values. Now the question is, do we have a bracket or a parentheses on 1? So 1 is included, x equals 1, that's included. So normally you would think it's a bracket. But at 1, -4, the function isn't increasing or decreasing. And because the question says, where is the function increasing, we are going to have a parentheses. Because at 1, the function isn't increasing or decreasing. So the answer is going to be 1, infinity. So when x is 1, x is 2, x is 3, x is 4, 5, 6, 7, 8, 9, the values of y are going to be increasing, so the function is increasing when x from the values of x as 1 to infinity. Okay? Part G says, where is the function decreasing? Okay, so same thing. We want to ask ourselves, and I'm going to give you a second to think about this, where are the y values decreasing? And I want you to highlight that portion on your graph. Okay, so where are the values of x decreasing? Well, the values of x are decreasing here in blue. Or sorry, the values of y, the values of y are decreasing 5, 0, -3. Or if you go left to right, the function is going downwards on this side. Okay, so let's think about that in terms of x. So the function is decreasing on this portion. Okay, how do you represent that in x values? Well, the arrow is going this way, so the x's get smaller and smaller and smaller, which means they're coming from -infinity. Okay? Where does the function stop decreasing? It stopped decreasing at 1 because after that it starts increasing. So from -infinity to 1, the function is decreasing. And at 1, you're not going to put a bracket, you're going to put a parentheses because at 1, it's not increasing or decreasing. Okay, so go over that one more time. This can be a very tricky concept, and if you have questions about it, that's totally fine. You should have questions. Write some down and come to class prepared with them, okay? But it's increasing when x equals 1, 2, 3, 4. So from 1 to infinity, it's increasing. What about decreasing? Well, -2, -1, 0, the function is decreasing. So from -infinity to 1, the function is decreasing. Blue is decreasing, red is increasing.